This example is for section 8-3, which is dealing with volume of a cone. And this is in your book on page 434. It is number 5. It is part of your homework. So I'm going to use it as an example. We're going to go through and work it. Now, they want to find the volume of the cone. Now, in order to find the volume of a cone, in the formula for the volume of a cone, you need the radius. And as you look at your diagram, we do not have the radius. The radius goes from the center of the circle here over to the circumference. We do not have that. However, we do have the height of the cone here, which is 40, and we do have the slant height of the cone, which is 41. And so, and notice that where the height comes up here and meets the radius, that is a right angle. So we have a right triangle. And since we do have a right triangle and we have two sides of that right triangle, then we can use the Pythagorean theorem. A squared plus B squared equals C squared. Now, you guys have done that before and used the Pythagorean theorem. And so what we have then is the hypotenuse here is 41. And so that would have to go where C is. So we put that there. We always find the hypotenuse, put it where C is. It goes on the side by itself. The 40 then is one of the legs. And we need to find the other leg, and I'm going to call it R because it is the radius that we are looking for. So I'm going to, instead of using A, I'm going to use R because I'm looking for the radius. And so now we have R squared plus 40 squared equals 41 squared, and we're going to solve for R. And so now I have R squared plus, and 40 times 40 is going to give me 1600. And then I'm going to square 41, which that would be 1,681. And I'm solving for R squared, so I've got to get 1,600 over to this side. So I'm going to subtract 1,600. I'll draw my line. That gets rid of those on this side. And that just leaves me R squared. And then 1,681 minus 1,600, that leaves me 81. And so now to get to R, we're going to have to take the square root of both sides. And the square root of R squared is just going to be R. And the square root of 81, that is a perfect square, which is going to be 9. And so we end up by using the Pythagorean theorem, because this is a right triangle, where the height comes in and meets the radius, that is a right angle. And since that's a right triangle, I can find the radius by using the Pythagorean theorem. So we have to do that first. And not on every problem will you have to do this, but on certain ones, if they don't give you like the radius, or if they don't give you the height, you know, they may give you the radius and may give you the slant height, and then you have to find the height. So you might have to use the Pythagorean theorem to find the height of the cone. All right. Now, sometimes they'll give you the radius and the height, and you won't have to do the Pythagorean theorem. You can go right to finding your volume of the cone by just using the volume formula. But on this particular one, we had to use the Pythagorean theorem to find the radius, and we had to do that first in order now that we can find our volume. So I'm going to write over here R equals 9. And so that I have the radius, and now since I've run out of room, I'm going to go ahead and erase this so that I can find the volume. Now, the first thing we always do is write the volume formula for a cone in this case. The formula for volume of a cone is V equals 1/3 pi r squared, which that's area of a circle again, pi r squared. So 1/3 of the area of the circle times the height. And so that is my formula for finding the volume of a cone. And so now I've got to plug in my number for R, which I know is 9, and then my height, which goes from the center of the base here down to this point. That is the height of the cone, which is 40. The 41 is the slant height. We do not use that when we're finding volume. So I'm going to plug in my numbers now. Since I have my formula, the 1/3 stays in there. I'm going to leave pi in there until the end, and then the radius was 9, and that's going to be squared, and my height is 40. And so once you write your formula, you plug in your numbers. And so we plugged in the radius, plugged in the height. We're leaving pi in there until the end. Now then, I want to deal with the exponent first. So the volume equals 1/3 pi times, and that's going to be 9 squared, which would be 81. And then we have 40 then on the outside. I'm going to rearrange my numbers here, and I'm going to put the 1/3 then times the 81 times the 40, and then I'm going to put pi here at the end. Since this is all multiplication, it doesn't matter how you arrange the numbers there. They're all going to be multiplied together, so it does not matter. Now, since 3 will go into 81, 1/3 of 81, that way I can take that, that'll get rid of the fraction there. 1/3 of 81 is 27, and then we've got then times 40 and then times pi, and so now we don't have a fraction to deal with. 27 times 40, we go ahead and we multiply those together. That's going to be 1080, and then we have our pi. Now, on this particular problem, it wanted you to round to the nearest tenth. So that means then I've got to plug in, and it also asks you to use 3.14. So I'm going to plug in for pi 3.14, and then I'm going to multiply those together, and that ends up giving me then 3,391 point, and it's going to be 2, because we're rounding to the nearest tenth, so I'm going to go ahead and round that, and we end up with our units is millimeters cubed, because volume is cubed. And so this is our final answer. So the volume of the cone there is going to be 3,391.2 millimeters cubed.